Bismillahirrahmanirrahim. Today we are going to speak about the two-dimensional coordinate system and the graphs. In this topic, we are going to speak about the coordinate system in two dimension, and then we are going to speak about the ordered pairs, distance between 2 points, and midpoints coordinate plus the graph of the sum given equations or functions. Start with the definition of the two-dimensional coordinate system. Start with this. What do you mean by two-dimensional coordinate? We know that for the real line, we have this line which is start from, we have 0, and we have positive 1 to the right, positive 2 up to plus infinity, and we have minus 1 to the left, minus 2 up to infinity. Because this line is in one dimension, because we can move either to the left or to the right, or any point on in this real line can be represented by single number, single value. If we add another line perpendicular to this one, 90 degrees, with the same partition, 0, plus 1 up, plus 2, go to plus infinity, and down, minus 1, minus 2, minus 3, going to the minus infinity, we call it two-dimensional coordinate system. So the two-dimensional coordinate system, it is just, we can say it is two perpendicular lines with 90 degrees, partition with the 0, 1 to the left, 0, minus 1 to the left, positive to the left, negative, or positive to the right, negative to the left, positive up, negative down. So we have this shape, but we call that coordinate system. So the two-dimensional coordinate system consists of two lines. Horizontal one, we call it x-axis, and vertical one, we call it the y-axis. And this coordinate system is divided to 4 regions, or quadrants. The first one we call the quadrant, or the first quadrant, quadrant number 1. Quadrant, or second quadrant, third quadrant, and fourth quadrant. The numbering is counterclockwise. First quadrant, second quadrant, third quadrant, and fourth quadrant. And the intersection point between the two lines, we call the origin. The origin. So this will be the main part of the coordinate system. We have horizontal axis, it is the x-axis, vertical axis, which we call it y-axis, and the origin point. Now, any point on the xy plane, we call it xy plane or two-dimensional coordinate system. Any point can be given by or represented by ordered pair. Ordered pair means that any point can be written as x and y. It has x value and y value. X value is the value on the x-axis, and y value is the value on the y-axis. This one, or this notation, we call it ordered pair. So any point in the xy plane or in the two-dimensional coordinate can be represented by this notation x, y. For example, we have this point, minus 3 and 1. It is a point on the xy plane. The x coordinate, we call x coordinate, and y coordinate. So we have the first value, we call it x coordinate, and the second one, we call it the y coordinate. For this point, the x coordinate is minus 3, and y coordinate is equal to 1. Again, any point represented by two numbers, two values, and that's why we call it two-dimensional. We have x and y, two-dimensional, two values. For example, the point 0 and 1. X value or x coordinate is equal to 0, and y coordinate is equal to 1. This point is 3 and 1. X coordinate is plus 3 and y coordinate is equal to 1. This point is 3 and minus 2. X value is 3 and y coordinate is minus 2. Usually the points to plot it in the xy plane, we start with the x value. This is 3. So go for 3 and minus 2 is the intersection between the two lines. X equal to 3 and y equal to minus 2. So this is the xy coordinate. For the equality of the ordered pairs, sometimes we speak about the equality of two ordered pairs. The ordered pair A, B, and C, D. These are two ordered pairs. They are equal if and only if the first coordinate in the first ordered pair equal to the first coordinate. If A equals C and B equal D. So two ordered pairs are equal if the first coordinate in the first ordered pair equal to the first coordinate in the second ordered pair. And second, or the y coordinate in the first ordered pair equal to the y coordinate in the second ordered pair. For example, if I have 3y equal to x minus 2, this example, 3y equal to x minus 2. These are equal if the first equal to the first means x equal to 3, and the second coordinate equal to the second, which means that y equal to minus 2. So two ordered pairs are equal if the first equal to the first and second equal to the second coordinate of the second one. For example, if I have D and 1 equal to C and, let's see, say 0 and 4, or I need to make it C variable. This means that D equal to 0 and C equal to 1. First with the first, second with the second. For the points on the xy plane, sometimes we need to speak about the distances. How can we measure the distance in between 2 points? So for that I have B1, which is given by x1, y1, and B2 given by x2, y2. And we need to find the distance between 2 points. If we are moving vertical, I have y2 minus y1. That will give me the difference in the y coordinate. Let me call it delta y. The difference in the y coordinate, delta y. y2 minus y1, or absolute value, because we are speaking about the distance, we have to make it positive. It is a positive quantity. And also, for the horizontal, let me call it delta x. It is the absolute value of x2 minus x1, or x1 minus x2, since it is inside absolute value, the order will not be important. Now, to find the distance between B1 and B2, we can think about it as like Pythagorean theorem. This is hypotenuse, the largest. If I call this is C, this is B, and this is A. Pythagorean theorem said that C square equal to B square plus A square, or C is equal to B square plus A square. Since it's given as D, I will use D now. So the distance now is given by square root of B square plus A square, and B is given by delta y, or y2 minus y1, and A is given by x2 minus x1. So we can say that in general, the distance formula is given by this equation or formula. The distance between 2 points D, B1, B2. Between the point B1, which is given by x1, y1, and B2, x2, y2 is given by square root of x2 minus x1 square plus y2 minus y1 square. For example, if we are given these 2 points, B1 is minus 3, 4. B2 is 7 and 2. The distance is given by x2 minus x1, y2 minus y1 square. If we say this is x1, y1, x2, y2, then I will have 7 minus 3 square plus 2 minus 4 all to power 2. I will have square root of 104. So the distance between 2 points, it is given by this formula. Square root of, I can say delta x square or x2 minus x1 square plus y2 minus y1 or square. More examples about this formula. Let's find the distance between the given points. First one, I have minus 5, 8, minus 10, 4, and I need to find the distance between these 2 points. So I will call this is x1, y1, x2, y2. So the distance, question number 6, is given by, formula is given by x2 minus x1 square plus y2 minus 1 y1 square, which is equal to x2 is minus 10, x1 is minus 5, and we have negative from the rule. This one, this is negative sign. We have to be careful. It is there, minus. So I will put the second coordinate with bracket. So it is minus. Plus, for the y coordinate, I have y2, which is given by 14, and y1 is 8. And we have negative or minus from the formula, which is this one. Then I will have, this is equal to square root of minus 10 minus 5 is plus 5, so it is minus 5 to power 2 plus 14 minus 8 is 6 to power 2, which is equal to square root of minus 5 to power 2 is 25 plus 36. This will give me square root of 61. So the distance between these 2 points is equal to square root of 61. Question number 8. We are given these 2 points, 40, 32, 36, and 20. Again, for 8, I will use this one as, this is x1, y1, x2, y2. Then the distance in this case, square root of square plus the y difference square. I have x2 is 36 and x1 is 40, and we have negative between them, difference from the formula. Y2 is 20, y1 is 32, and negative sign from the formula. We have to put it in this way so that we will not mix this with the negative with the coordinate sometimes. So I will have square root of 36 minus 40 is 4, or minus 4 square, plus 20 minus 32 is minus 12 square. That will give me 16 plus 144. That will be square root of 160. This can be simplified to be 4 square root of 10. For the third one, I have 0, 0, 5, 13. Question number 10. The points are 0, 0, and 5 and 13. And we need to find the distance of this one, or between these 2 points. It will be square root of 5 minus 0 square plus 13 minus 0 square. That will be 25 square plus 13 square is 169. So this is 194. So the distance between these 2 points, 0, 0, 5, 13 is equal to square root of 194. So this is the idea of how to find the distance between 2 points. It is the difference between the x coordinate and square it plus the difference between the y coordinates and square it. So delta x square plus delta y square under the square root.